So we've officially reached the end of chapter 3. And so now what we're going to do is just like we would do in class, we're going to do our chapter 3 review. And I'm going to give you an opportunity to try each question. So before each one, it's going to pop up as a multiple choice problem. And you'll get your opportunity to take a shot at it. Try your best. Don't just guess, but try your best on it. It doesn't matter what your score is on this review. I'm just looking to see that you tried it. And try each problem. If you get it right, awesome. If you don't, that's okay. I'm going to go through each one. And so if you get it right, just make sure you did the same work as me. And if you got it wrong, that's okay. Just know how to do it for the test on Wednesday. So here is our chapter 3 review. Question number 1. A card is drawn from a standard deck and not replaced. Then a second card is drawn. What is the probability that both cards are hearts? So what's important is not replaced. It means that this is not mutually exclusive, okay? So if we think of it, if we want a heart, there are generally 13 hearts in a deck of 52 cards. But assuming that we take one heart out, there would now be 12 of them and only 51 total cards, right? So if we wanted to figure out what this probability is, I would multiply those, and I can actually go just to my calculator, and I am going to do 13 over 52 times 12 out of 51, and I get the fraction 1/17. So I go back here, and I say that this is 1/17, right? And so I get C as my answer. Okay, question number 2. Find the probability that a point is chosen in the square. So this is one of those geometric probabilities. So we need to know some area problems. So the first one, I need to know the area of my square right here. And we remember that the area of a square are the side lengths squared, right? And so if I know that half of the square is 2, the full side of it is going to be 4. And so I'm taking my sides of 4 and I'm squaring it. And I get a total of 16 units squared. Now I'm asked to find the area of the circle, right? And maybe you forgot how to find area of a circle, and that's okay. It's pi r squared. This would be something you're probably going to want to know for your test. So pi r squared. So we're going to say that it's pi times, and r is the radius. Now if half of the circle is 2, and then all the way out to the end is 3, that's a total of 5 units squared. And so what I do is I'm just going to go to my calculator, and I'm going to say pi times 5 squared is 78.4. So I write 78.54. 54. Okay. Now if I wanted to figure out my probability, all I'm going to do is I'm just going to take 16 divided by that. So 16 divided by 78.54. I go to decimals, and I do 16 divided by 78.54, and I get just about 20%. So this is 20%, or 0.2, and that would be C. So again, for number 2, we get C. Now, number 3, it says 6 people are randomly sat around a round table. What is the probability that the people are sitting in alphabetical order? So if we think about this, if we have a table, and I have 6 people at this table, right? 1, 2, 3, 4, 5, and 6. And we're assuming that they are in alphabetical order, or what's the probability they are. So let's say this person starts with A, B, C, D, E, and F. So that's one opportunity, right? But now let's say we have our circle again, and again we have our 6 people. 1, 2, 3, 4, 5, 6. But let's say now A is right here, and B, C, D, E, and F. So although they are still in alphabetical order, they're just rotated 1. So what we did to take account of that is we said, okay, so person A has 1, 2, 3, 4, 5, 6 areas they can sit. 6 areas. And then Person B has 5 areas, 4, 3. Person E would have 2 areas, and person F would only have the 1. So we call that 6 factorial. However, there's 1, and if I rotate A, that's 2. If I rotate B, A again, that would be a third option. And then if I rotated A so that he's now in the position where D was, that would be a fourth option. What if A was in the spot where E was? That would be a fifth option. And where F is, that'd be a sixth option. So there's 6 ways that it could still be alphabetical. So we divide it by 6. So what we can do, and our formula was this. We called it n factorial over n. So this is for circle permutations, right? And so that would be one that you probably want in your notes, circle permutations. And so what we're going to do is we're going to go to our calculator, and we're going to do that. We're going to say 6 factorial. Let's see, factorial. And then divided by 6 is 120. So I go back here, and so the chance of it would be 1 out of 120 because we've taken into account all 6 ways it could happen. So 1 out of 120 different ways. Okay. Now, for number 4, it says calculate the expected value of a dart game with the dartboard shown. Okay, so remember, to find expected value, what we're going to do is we're going to find the probability. We find our probability times its value. And then we do that for every one of them, and then we're going to add them up. So what we're going to do first is we're going to find the area. I'll color these of the orange circle, then of the kind of green circle, and then of the purple circle on the outside. Okay, we'll find their probabilities, and then we'll multiply by their point value because each one has a different point value. All right, so orange. Probability of orange. Well, first the area of that is, and I'm going to erase so we can see. I see that the diameter is 6, so my radius is going to be 3. So the area of this is going to be pi times 3 squared divided by the area of the whole thing. So the area of the whole square is going to be, well, if this is 3, 4, 5, 6, 7. So divided by pi times 7 squared. And so doing a little bit of math, you see that the pi's cancel out, and so 3 squared is 9 over 49. That's the area. So the probability would be 9 out of 49. Okay? Now, let's find the probability of green. So that would be, probability of green would be, well, we know that it's 3 and then 4, 5, so it would be pi times 5 squared over pi times 7 squared, the whole circle. And so then that would be 25 over 49. However, you'll notice that the green only goes around what we already had, so we have to subtract 9 49ths from it because the orange is already taken away. So that would be 16 out of 49. Okay, so that's my probability of the green one. And now the purple one, its probability would be the area, which is pi times, well, let's see, 3, 4, 5, 6, 7 pi over pi times 7 squared. So you'll notice this is just 49 over 49, but I got to take away this 29 out of 49 because all of the green circle is gone. So minus 25 out of 49. And so that's a total of 24 over 49. So now what we've done is, and if you added them up, 24 plus 16 would be 40, plus 9 would be 49. So those are the probabilities. Now to find expected value, what we're going to have to do is take these values and multiply them by their point total and then add them up. Okay, so I'm going to do that over here. Okay, so expected value. Okay, is equal to, or I guess we call it EX. All right, so we're going to take the first one. So P1 is going to be 9 over 49 times, and that one's worth 300 points, right? And then P2 is going to be 16 over 49, and that's worth 200 points. And then finally the last one, P3, is 24 over 49, and that's times 100 points. And what we're going to do is we're going to take all of these and add them all together, okay? So let's do that. So I'm going to go to Desmos, and I'm just going to look at it from there, and then we're just going to write it down, okay? So first one, I had 9 over 49 times 300 points. So that's 55.1, okay? The next one was 16 out of 49 times 200 points, 65. And the last one was 24 out of 49 times 100 points. Oops. Okay, and that's 48.9. So now for the next one, I'm literally just going to add my three numbers together. This number, and this number. I'm going to add them all together, okay? So what we do is we say, okay, 55.10, I'll just do two decimal places, that's fine, plus 65.31 plus 48.98, and that's 169.39. So I go back here and I say 169.39 is very close to C, which is 169.4. Now it seems like a lot of work, and this one can be quite a bit of work, but hopefully in a problem that you have like on your test, the expected value problem is a little easier, because sometimes they can be really easy. All right, now, okay, now number 5 says 3 of 10 people in the Latin club are chosen at random to wear togas to the school, or to promote their school club. What is the probability that Joseph, Heidi, and Katie are chosen? So I want you to notice one thing, because there's going to be lots of problems on here where they're asking about different things, where they choose a certain number of people. Now this is one where they choose 3 people, and there's 10 total, right? So 10, and we'll call that N, and the R is going to be 3. Now there's 2 choices. There is either NCR or there is NPR, right? And so here's the difference between them. Okay, ready? In a P, a permutation, order matters. So this would be one where they say, what is the chance that Joseph, Heidi, and Katie are chosen in that order? Now you'll notice the order matters. So this would be a permutation. But they don't ask us that. And so then if they don't ask us that, this is called a combination. And so this is when order does not, I kind of ran out of it, doesn't matter, right? Okay, so this is when order doesn't matter. And so we have a combination in here. Okay, so what we're going to do is we're going to go to Desmos, and it's actually one of our functions. So if you'll notice, okay, first I got to get rid of these. But you'll notice that here in the function section right there, okay, I can click on that. And when I do, I have a combination button, right? You see this NCR? N, our first number, we said was 10, comma, and then our R is going to be 3, because we care about 3 of them, okay? And so I do NCR, 10, 3, and I get 120. So what that means is the probability of these 3 getting chosen is 1 out of 120, which our answer would be C. Okay. Now, number 6. Number 6, what is the probability that a random selected permutation of letters, so remember, order matters. Permutation of letters AACCLLORTU would spell out calculator. Now, we had a special thing in our notes that we used for this. Now, if you looked at section 3.2, this was our permutation with repetition. And so what that did is it took all of the number of letters that we had, n, and it took that factorial divided by, and it took each one and the number of times they were repeated. So the r's on the bottom are repeated roots. So that's what we're going to do here. We're going to say, okay, I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So I'm going to do 10 factorial divided by, and I look at each one. So I have 2 A's, I have 2 C's, I have 2 L's, I have 1 O, 1 R, 1 T, and 1 U. So I don't have to write those 1 factorials because those are just going to be 1. So this right here is what I'm going to put into my calculator. Okay, so I go there, I go to decimals, and I do 10 factorial, and then I do that divided by, okay, 2 factorial times 2 factorial times 2 factorial. And I get a kind of a big number. I get 453,600. So the chance of that happening is 1 out of 453,600, right? Interesting. There's only 10 letters there, but the chance of spelling out calculator randomly is not very good. Okay? All right. Number 7. Number 7, it says, Maya's senior class of 100 students, 89% attended the senior brunch. If 2 students are chosen at random from the entire class, what is the probability that at least one of the students did not attend the brunch? Okay, so at least one. So if at least one did that, okay, so if I have 2 students, all right, I have student 1 and I have student 2. So at least one of the students did not attend the brunch. So that could be either A, did not, student 1 did not, or student 2 did not, or both of them did not, right? So the way we do this is we do a conjugate, which is an opposite, right? And so what that means is we're going to take the probability of both of them attending and then do 1 minus. 1 minus the probability of both attend, right? Which seems interesting, and you can do it the other way, but it's maybe a little bit more work. Okay, so this way is probably the fastest. So what we're going to do is we're going to say the probability of them both attending is this. Okay, so it says the first student attending the brunch was 89%, so 0.89. Probability of the second one, 0.89 also, right? And so I'm going to do 1 minus this, and I get, if I go to my calculator, 1 minus, and then in parentheses, 89% of the first student and 89% that the second student goes. And so I get this 21% basically. So what is the probability that at least one of them did not go? It's 21%. All right. So this is one I think you may want to make a note of, because it will definitely, if you know how to do this one and how we did this one today, it will help you significantly on the test. And if you have any questions or you're confused on a problem like that, make sure you make note of it, and we can talk about it in our live session when we go over questions, okay? All right, number 8. What is the probability of drawing a 2 or a heart from a standard deck? Okay, so you'll notice it's an OR problem. Okay, so we're going to multiply the probabilities. So the probability of a 2 and the probability of a heart. Okay, so the probability of drawing a 2, okay, well, there are 4 2s out of 52, right? And there are, okay, we're going to add these. And the probability of a heart would be 13 out of 52. But here's the question. There is also a 2 of hearts, which has been counted twice. And so we're going to subtract 1 out of 52. And so what ends up happening is I get 4 plus 13 is 17, minus 1 is 16 out of 52. And I look over there and I notice I don't have 16 out of 52. So my first thought would be, uh-oh, I did this wrong. But what I want you to do is I want you to go to your calculator and simplify. 13 divided by 52 is 1 out of 4. Oh, I think I did that wrong. 16 out of 52. 16 out of 52 is 4 out of 13, which you actually do see is one of our options. It's option D. So the correct answer to this one is 4 out of 13. Okay? All right, next one. Number 9. A pair of dice is rolled. What is the probability that a 1 is showing on both die? Okay, so the probability of a 1 and a 1. Well, the probability of a 1 on the first die is 1 out of 6, times the probability of a 1 on the second die is 1 out of 6. So the probability of them both being 1s is 1 out of 36. And remember, when we multiply fractions, top times top is 1, bottom times bottom is 36. So 1 out of 36, so A. Number 10. The law of large numbers says that the more trials or simulations, or of a simulation you conduct, the difference between the average and the expected value, what? All right, so the difference between the average and the expected value. So think about it. If I was going to flip a coin, right, coin heads or tails, you could probably tell me that it's going to be, it should be 50-50, right? That's what it should be. But we know as the first couple times you flip, it's not always 50-50. You might get more heads, you might get more tails. So what happens is as you continue to have more trials of a simulation, the difference between the average and the expected value remains the same. So, so essentially what's going to happen is they are going to end up being the same, right? They should be in the end. Yeah. Right? Number 11. Last year, 45% of the books ordered from the school library were fiction. Which model could be used in a simulation to conduct and find the probability of whether or not a book chosen randomly from this year's order will be fiction? So, first one, it says a spinner with sectors of 45 degrees and 55 degrees. I'm telling you it's not going to be A, because 45 degrees plus 55 degrees only adds up to 100 degrees, which we know a circle that a spinner should be 360. So that's not 360 degrees, so that does not work. Okay, so it can't be A. Let's go to B. A spinner with sectors of 162 and 198. I'm not quite sure about that, so I'll put a question mark. I'll go to the next one. Tossing a coin 45 times. Now, 45% and 45 times on a coin are not the same thing. It's not going to be C. And then it says 45% or 45 marbles. Again, they're not the same. So the correct answer is B. But why is it B? Okay? Well, the reason it's B is this. 45% or 0.45 of 360 degrees, so times 360 degrees, would be, well, let's check our calculator. 0.45, oops. And times 360 degrees is 162 degrees. You'll notice 162 degrees is right there. And so I bet you can guess that what 55% of that is going to be, the chance of them not being fiction. and that's 198. And so you'll find out that those sections right there are the two halves, or two parts, I guess, of the spinner that we would want. So the correct answer to 11 is B. All right, number 12. A spinner consists of a shaded red, or contains a sector shaded red with a central angle of 50 degrees. What is the probability that the spinner will land on red? Okay, so we just did one very similar to it. So here is our spinner, and our sector that is red is right about here. So this is shaded red, right? And so we said that's 50 degrees. But a whole circle is 360 degrees. So the chance of you landing in that red sector is 50 out of 360. And so what we can do is we can actually just simplify that down. Go to our calculator. 50 divided by 360 is 5 over 36. And so the correct answer to this one would be D. Number 13. Okay. Carlos can choose from a beef or turkey burger and from a wheat or white roll. How many different burgers can he make? Okay, so this is the fundamental counting principle. All right. Now the name doesn't really matter, but what it does. And so we said that if we look at the type or number of burgers there's two options, and the number of buns options there are, which is 2. So how many different burgers can he make? Well, what we would do is we would take this number, which would be 2, times this number, which would be 2, and there are 4 different options. Now, if you wanted to write each one out, you could say beef and a wheat roll, or beef and a white roll, or you could have a turkey and a wheat roll, a turkey and a white roll. And you'll notice there are 4 different options, which is what we just said. So there are 4 different burger combinations. Okay, here's number 14. It says, what is the probability of drawing a card from a standard deck and not drawing a face card? Okay, not drawing a face card. So we got to think about, well, how many not face cards are there? Well, there are 4 decks, or 4 suits, 4 suits. And there's Jack, Queen, King. I think we're going to count an ace, right? Probably not an ace, actually, now that we think about it. Let's just say not an ace. So there's 3. So 4 times 3, there'd be a total of 12 face cards, right? So what we're going to do is we're going to take, of the 52, taking away the 12 face cards, that's 40 out of 52. And so we can change that. We go to our calculator, and we say 40 over 52 reduces down to 10 out of 13. And so what's the probability of not getting a face card? It's 10 out of 13, which is option B. Okay, number 15. Find the number of possible outcomes for a weekend camping trip from 4 places to camp, 2 types of sleeping bags, 3 types of tents, and 5 different meal plans. So just like that fundamental counting principle, again, fundamental counting principle, okay? Again, the name doesn't matter, but what it does. Okay, 4 places to camp times 2 sleeping bags times 3 tents times 5 meal plans. Now this would be one that, unlike the turkey burger example, I can write out real easily. This one, however, there is not an easy way to write this out. It would be very messy. So what we're going to do is we're just going to put it in our calculator. And we do 4 times 2 times 3 times 5. Making sure that's right. 4 times 2 times 3 times 5 is 120. Okay, so how many different possible outcomes for the weekend are there? 120 different outcomes. All right, number 16. The 5 posters made for Spirit Week are beginning to be hung in the front hall. What is the probability that the largest poster will be in the center and the next largest will be on its left? So now we're looking at a total of 5, and we're interested in 2 posters, and we notice that order does matter. So this is a permutation, right? So that means we need to use our NPR function on our calculator, which would be 5 comma 2. And so we go to that on our calculator, and we would say, go to the function section. Okay, remember function section. And we do NPR, which would be this one. And we're looking at specifically 5 and 2. There are 20 different ways the poster could be hung. And so I look at this. So this would be 1 out of 20. It would be C for this option. All right. Number 7. If a die is rolled 3 times, what is the number of possible outcomes? Okay. So again, this one is a fundamental counting principle problem. Okay, so the first time I roll the die, I have 6 outcomes. The next time I roll the die, there are also 6 outcomes. And finally, the last one, okay, 6 outcomes. And so that would be the same as 6 to the third, which would be what? That would be 216. And so there are 216 possible outcomes if we roll our die. Finally, the last one, question 18. Point X is chosen at random on Ym. Find the probability that X, and that's what this means, probability that X is on YZ. So I'm going to assume my little point X is right here on YZ, which is 2 in length. Somewhere in there it's going to be 2 out of the whole thing, Ym. And so to figure that out, it would be, well, the first part is 2, and I have 5, and I have 2 more. That's a total of 9. This would be 2 out of 9. And if you're not sure what that is as a percentage, what we can do is go to our calculator, and we would do 2 divided by 9, which is 0.2 repeated, which means it would be A, 22%. Well, I hope this review was not too challenging for you. If you had a couple questions, or if there's anything you want some clarification on, or you just weren't sure about, make sure you keep note of that and bring it up in our question and answer session on Tuesday. Have a great day, guys.